Good afternoon. This is Karen Salmon, CEO of Force Technologies, and welcome to the third podcast, which we have named Force Tech Talk. I'm sure I could say that on a couple of gins, but never mind. We had a busy February. We attended the IIOM, Institute of Obsolescence Management meeting in Wiltshire, in Swindon, in February, and somebody asked us about reliability. So the aerospace and defence industry, as we know, is some of the equipment that we sell into. It's critical, safety critical, life-saving critical. And somebody asked us what Force actually do with regards to reliability. But first of all, Ben, can you just explain to us where certain failures could be caused on a system?
Yeah, I mean, there's three main failures you can sort of, isolate them down to. One would be just a sort of straight electrical failure, generally as a result of improper screening before it goes into the application. Mm-hmm. The second one would be a device failing in the environment, so, breaking apart due to high G forces or temperature extremes, etc., damaging the component. And then the third would be if a counterfeit device in any manner sort of found its way into a customer's system, and it could fail as a result of the first two things that I outlined, because it's counterfeit, or because it's not remotely what it actually is and what it's been labelled as when it goes into the system. It doesn't perform the role that it should be performing.
I was going to say, Charlotte, what's your definition of counterfeit for those people who are watching who maybe not know? I don't mean a fake Louis Vuitton bag that you buy on a Turkey beach.
The counterfeit component. A counterfeit component, I mean, is not what it says on the tin. It's marked incorrectly. Maybe the manufacturer is completely different. Maybe the die inside is completely different. It's not what you're expecting. Someone is buying a component, expecting it to behave and function and look a certain way. And when it comes in, if it deviates from that, then you can pretty much call that a counterfeit. And the market at the moment is flooded with counterfeits. Unfortunately, there's lots of lawsuits that I'm sure we've all seen in the news recently about counterfeits making their way onto aviation systems, defense systems. So, yeah, counterfeits definitely a scary, scary place to deal with.
And what do we do at Force? I mean, obviously, quality is one of our core values, and for those listeners who don't know, we are AS9100 REVD, which is a accreditation. And we get audited every year without non-conformances, may I say, thanks to the quality team. So, we're pretty hot on that. But how do we deal with testing our failures so our quality stays good?
Yes, I mean, the going back to the sort of first failure that I talked about, where a device has been improperly screened, electrical components, like most electrical goods, they can have what's called an infant mortality, which is just really where the chip dies in the early stages of its life. The mill standard specification and other specifications call out a what's called a burn-in test, and a burn-in test is effectively a high stress test that you do for a period of time that lets you confirm that the device is going to not fail in its early stages of operation. Okay. So we do that on all of all mill products that we provide. Going on to sort of the second, where you have an environmental failure, there's a whole suite of environmental tests that get conducted on IC, from constant acceleration, which is like a high, you sort of mount a part into a centrifuge and spin it very fast and see if it breaks and shatters, and if it doesn't, then it's good. But then there's a whole bunch of others, including temperature cycling, which rapidly increases and decreases the temperature to confirm that the part's not going to be damaged from that. Alongside other electrical tests and shock and vibration tests to ensure that when a device reaches a customer, that it's not going to have any problems in its operation over a long period of time.
A lot of your aircraft customers ask for shock and vibration, don't they?
Yeah, well, they have to. Like you say, they're flying in harsh environments, very high stakes and pieces of equipment. They have to have basically zero margin for error. So we have to put the chips through all those types of testings that they're going to experience when they're flying. So yeah, definitely it's super important with aerospace and defense especially.
Yeah.
what I found over the last 2-3 years is I know we do our specific tests for mill standard 883, but a lot of customers are asking for extra testing now, aren't they? And so we have to keep writing our QM specs for listeners who don't know who that is. That's our specific spec for certain customers. And they're asking for more and more, aren't they, Charlotte? They're asking for extra testing than what we normally do.
Yeah, they'll ask for, because each customer, depending on the application they're putting it in, they have, their own specific tests that they want done. In addition to the mill standard 883, they might say, we also, for our program, we need this done as well. And of course, we can accommodate that. When an inquiry comes in, we capture the whole requirement. We say, what specifications do you need? What testing do you need? And we capture all of that. Well, your team captures all of that.
Yeah, I think it's very important. Some customers have very exacting specifications that they need, and that makes our life a lot easier when they have all of that data. And in some situations, a customer's trying to revive a part that they barely got a data sheet for, and we have to go around and work out exactly what they were using originally and ensure that what we're providing is gonna work for them.
And isn't it difficult when they give you a manufacturer's part that's gone obsolete? It's all very well. The data sheet's pretty simple on how to package it, and where there's a drawing and that's the die and there's the parameters. But when it comes to testing, some of these old data sheets don't have a lot of testing data on them, do they?
No,
they don't have a lot of reliability data on them. So we're kind of starting from scratch, aren't we?
Yeah, I mean, it's certainly the test hardware and software to test these old components. If we haven't got it in our library, then it's going to be from scratch development, which can be costly, and you really have to make sure the device gets exercised properly. So,
but your team is so good at that.
I mean, we've been doing it now for many years. I mean,
yeah. Well, 16 years for you. Yeah. I'd like to know how many test programs you've written in 16 years. Maybe that's another conversation that we can have. But also, I mean, people say Force, yes, we keep saying we've been around for a long time, but we actually have, and a lot of the stuff we have instigated and developed over the years, for instance, Authenticare. I think we actually maybe started Authenticare just as you joined the company. And again, for those viewers who don't know what it is, Authenticare was designed to, again, test product to different levels for anti-counterfeiting, and we trademarked it. And then over the years, it's been developed into AS9081, which your team makes sure all the aspects are tested, aren't they?
Yeah, I mean, most aerospace and military customers now are pretty much adhering strictly to the AS9081 specification to rule out any counterfeits getting into their systems and subsystems. So,
but there's different levels of AS9081, isn't there? There's A.
It goes all the way from A to G, I think. Yeah. Traditionally, most customers want to see A to C.
1 to 6, and a C. So C's electrical test, and then your A categories or your kind of physical dimensions, X-ray, DCAP, things like that, just to make sure what's inside is what you're expecting and has all the amount of pins and things like that.
Do customers ever say to you, Charlotte, I'll just go with the basics because they don't want the cost issue? And then they change their mind and come back to say, maybe we'll just test it a bit more.
I think generally there are some customers that say that, but once you explain to them what the levels of testing and the problems it's going to prevent in the future, they're pretty much, the cost difference between it is not massive. So, a lot of the time they're happy just to have an AS9081 as the industry standard would expect. They wouldn't cut that down, especially depending on the application. It can be non-negotiable in some instances.
Yeah, I mean, your team work very hard on the AS9081 parameters and stuff, don't you?
Yeah, I mean, it's very important to ensure that what a customer receives is exactly what it should be. But at the end of the day, the customer signs off the report, and it has to be them who make the final decision on whether or not a device is suitable for their application.
So after we do the testing, and then we send them a report, don't we?
Yes.
And then they agree that what we've done is fine. So we've got everything covered. Yeah, brilliant. Okay, well, thanks for that, guys. Love talking about Authenticare in the old days.
Yeah, and please keep your questions coming in. I mean, I know we had a brief question on what's the difference between an industrial and a military device, and perhaps we can talk about that next time.
Yeah, let's talk about that next time. So if any of you want to know for the next podcast what is the difference between an industrial and military grade products, Ben Head of Engineering, and Charlotte, Sales Manager, and myself will be happy to answer those questions. Until April, bye for now.